Welcome to the lecture series on deep learning in artificial neural networks. This video covers the summary and the quiz in the context of statistical classification by deep networks. So what we have seen is that in the case of a single class problem, we should use a sigmoidal unit so as to allow a statistical interpretation of the neural network. In the case of a multi-class problem with exclusive multiple classes, we should use a softmax function that corresponds to an effective interaction between the output units. And generally, it's widely accepted then that for hidden layers, one should use rectified linear units, even though there is no deep theoretical justification. There's no deep justification in the context of statistical interpretation. We also looked at error functions, and we saw that for single class problems, the cross-entropy loss is appropriate in order to allow a interpretation in a statistical context, whereas for multi-class problems with mutually exclusive classes, we should use a slightly different formulation of this cross-entropy loss. Now let's sum up everything with a little quiz. So let's look at the little quiz. First question: a softmax unit should be used for exclusive multi-class problems in an output layer when we use one-hot coding to represent its classes. If you think that is correct, raise your hand now, and yes, this is correct. Sigmoidal units should be used for multiple attribute classification problems. Is this correct? Yes, that is correct. Two-class problems of the mutually exclusive type are the same as single class problems. You may want to think about this. And yes, this is correct. If I have only two classes, A and B, then if I don't take A, I have to take B. So it's the same. Multiple attribute class problems are treated as multiple single class problems. Yes, we have seen that. Now we have 4 positive answers. Next question: the above choices guarantee that the outputs can be interpreted as probabilities. Do you think that is correct? No, this is not correct. Next possibility: we need to be careful if we want to interpret the output as a probability. And yes, this is correct. Now let's continue with a further quiz. Suppose we minimize, in a multi-class setting, the cross-entropy loss with respect to the model parameters. Okay, so we use the cross-entropy loss as an error function. The parameters are the weights and thresholds of our multi-layer neural network. Then the final set of parameters at the global minimum corresponds to the maximum likelihood solution in the statistical sense. Think about this. And yes, this is correct. Now, second problem. We have a problem with 2 mutually exclusive classes. Now, Albert uses softmax for the 2 outputs of his neural networks and minimizes the cross-entropy loss defined here. Now, Berta works on the same problem, but she uses a single output in her network, and she uses a sigmoidal unit for it and minimizes a slightly different loss described here. Now think about it. You have 3 possibilities. At the global minimum, the 2 solutions are completely equivalent. Both approaches work, but the solution of Berta is slightly better. Or Both approaches work, but the solution of Albert is slightly better. Think about it. And the first answer is correct. So even though the cross-entropy error functions look slightly different in the two cases, it's compensated by the fact that one uses a softmax and the other uses a sigmoidal. And then, as said on the previous slide, a two-class exclusive problem is the same as a one-class problem. And it's mathematically completely equivalent, so both will find the same solution. So these were the objectives for today. We went over the cross-entropy error function and indicated that this is somehow the optimal loss function for classification tasks. The sigmoidal, or softmax, is the optimal output unit for classification tasks. Exclusive multi-class problems use one-hot coding, and under certain rather restrictive conditions, we may interpret the output as a probability. And of course, there are many textbooks that cover these topics that are absolutely standard, that are foundational for the field of statistical learning.